Hello, my name is Anmol Soni, and today we'll be learning a topic force and pressure. What is force? In our everyday life, we pull or push objects, so that requires force. This force has a SI unit or System International Unit known as Newton, which is denoted by N. So we cannot actually see or touch force, we can only feel its presence. Now, what are the effects of force? So, force has five effects. Force can make a stationary object move. You have a football and you apply force from this side or you kick from this side. Kicking is basically applying force because you kick an object which makes the object move. If you kick this ball, the ball will move towards this side. So that means you are applying a force on the object which is making the ball move towards the side. Force can change the speed of a moving object. So for example, you have a shopping cart with two wheels. So the shopping cart is already moving at, let's say, 3 kilometers per hour. So it's already moving at this direction at 3 kilometers per hour. So if you go on and apply more force in the shopping cart, you might change the speed of the shopping cart. If you apply more force, the shopping cart can move at any speed. For example, let's take at 7 kilometers per hour. So we can hence prove that force can change the speed of a moving object. Force can also stop a moving object. You have a goalpost, a goalkeeper. So what does a goalkeeper do? He uses his hands to block the ball. The force of his hand stops the ball, and we can hence prove that force can stop a moving object. Force can also change the direction of a moving object. Let's say you're playing cricket. This is your bat. The baller balls and the ball is coming from this direction, from here to here, point A to point B. Point B is basically the moment before you hit the ball. And then the moment you hit the ball lands here, and then the ball directly, for example, goes here. So this, like, you're basically changing the direction of the ball. So this is point B and this is point C, the direction where the ball is going. So from this we can prove that force can change the direction of a moving object. Force can also change the speed of an object. So now this and this are interconnected. Let me explain. So now you have force can change the speed of an object, and here force can change the speed of a moving object. So here the object is actually stationary, and here the object is already moving at 3 kilometers per hour. And how are these both interconnected? So here you're talking about force making a stationary object move, and here also a stationary object is actually moving. When you apply force from this side, the ball moves this side, but at a certain speed, let's say 10 kilometers per hour. So this is a certain speed the ball is moving at. So now force can be of 8 types: gravitational, non-contact, magnetic, contact, electrostatic, frictional, muscular, and mechanical force. Contact force. So when we kick a football, the force arises because of the contact of our foot and the ball. So any force which has a contact of two objects, like in this case foot and the ball, is known as contact force. Muscular force. So the force being acted upon our muscles, like pushing, pulling, lifting, or even dropping something, requires muscular force. Even the slightest thing requires muscular force, like moving an object. So the force required by our muscles is known as a muscular force. A ball moving on the ground comes to a stop on its own because of frictional force. The force which slows down an object or a moving object is known as frictional force. The direction of this force is opposite to the direction of motion. The force that opposes motion when two substances comes in contact is known as frictional force. Mechanical force. Now let's say we have a car engine, a car motor, and petrol. We'll denote them by A, B, and C respectively. So you use petrol to power up the car's motor, which powers up the car's engine. So the petrol, which is like the fuel of the car, powers the motor, which powers the engine. So this creates the force which moves the car. in a selected direction. Non-contact force. So now you have a leaf falling towards the ground. And this is the bark of a tree. The leaf is already in this area. So now it is not touching the ground, nor it is touching the bark of the leaf. So it has no contact of anything whatsoever in this moment. So this is known as non-contact force. When a substance which is already in motion but is not touching any of the solids is known as non-contact force. Gravitational force. So anything in the universe, even this 20 kgs of box, has an attraction. But the attraction of this is too small for us to feel. Even moon, it has a gravitational attraction. It is like 1/6 of Earth. So a person weighing 60 kgs on Earth will weigh around 10 kgs on moon. So how does this happen? This is because of gravitational force. For example, this is the surface of Earth, and this line you see here is the gravitational boundary of Earth. To escape this boundary, you need around 11.186 kilometers per second to escape. That's quite fast of a speed. So this is known as escape velocity. So gravitational force pulls whatever which is in its boundary. For example, Earth. The person weighing 10 kgs of moon can weigh 60 kgs on Earth. This is because of gravitational force. Magnetic force. The force applied by a magnet is known as magnetic force. This is either counted in attraction or repulsion. So you have a magnet, and it has a magnet, as you know, has two poles, north and south. So we take a magnet here, scenario 1. So this is the north pole of the magnet, and this is the south pole of the magnet. And we have another magnet, but here, this is the north pole again of the magnet, and this is the south pole. What will happen? What do you think will happen? The magnet will actually attract. But in scenario 2, you have a magnet like this. This side is south, and this side is north. And the second magnet has two poles here, but this side will be north, and this side will be south. Now what do you think will happen? These both magnets will repel, not attract. We can hence prove that same poles repel and opposite poles attract. So the next force we have is electrostatic force. So when you have two charged or one charged and one uncharged particle, so uncharged particle acts upon this charged or uncharged particle. This is known as electrostatic force. So electrostatic force occurs when a charged or an uncharged particle or anything is rubbed against each other. Action of two or more forces. For example, you're in a game of tug of war. So this is team A and this is team B. If both the forces of team A and team B are equal, so this is equal force. So nothing special is going to happen here. But if team A pulls harder, the more force is being applied by team A, and as there's more force, the rope is going to go towards team A. If team B applies more force, the rope will go towards team B because there's more force being applied from the side of team B. So this is known as action of two or more forces. So that's all for this video. Thank you for watching, and please stay tuned for my upcoming videos.